Hello, I am Affan Ahmed Khan, mechanical engineer with expertise in computational biomechanics and bioengineering related to design and simulation of complex parts like femur bone, human knee joint, ankle joint, hip joint, strand, prosthesis, etc. In this video, I will show I have designed the intramedullary nailing for femoral shaft fracture, the longest bone in human body that is mostly broken by motor vehicle accident. It is very strong bone. Generally, it is not broken, but when struck in accident or any other motor vehicle phenomena, it will break down. So to handle down that accident, we have designed femur bone, who is spelling mistake, FEMEU. First we design femur bone with the help of Solidworks, Fusion 360 or PTC Creo. You have seen my femur bone. Oh, it is not my femur bone, it is human femur bone, and the analysis is running Ansys software. So you clearly seen the stress is generated one mysis stress or other. Anyway, this is femur bone and PTC Creo or Solidworks version. So this is femur bone, this is femoral condyles, femoral shaft. Actually, femur bone is broken in this way. This you can see the two cuts here. One cut is horizontal and one is inclined at 45-degree angle. So this is a major accident, maybe like motor vehicle accident or any other, that broke femur into two parts. So what we have to do, we have create a hollow section. See my mouse here, hollow section that passes these two areas. The hollow canal known as medullary canal, and when where we will insert a metallic rod made up of biomaterial, mainly 316 stainless steel, low carbon, or titanium alloy Ti6Al4EV, or many researchers use cobalt chromium alloy. So but we use titanium alloy or 316L stainless steel. So we will enter a biomaterial rod here and put screw here, interference screw here, to tighten that rod. You can see my mouse. This is for screw, two holes. Okay, yes, this is final image, and you can see the red rod here. This will save the femur bone, and these two screw will tighten here, and one screw at the bottom of hip bone, that will tight here. So this is complete. Or yes, this is very clear picture. You can see this, and the red rod is made up of biomaterial. I have told you before, and this will save my or other femur bone. So what are the steps and that by following created? Step 3. Step 2, create cylindrical hollow path for medullary canal. Was created by extrude cut by making spline or any other ellipse type section, then extrude up to whole length up to femoral condyle. The IGS file is the file that is used to import in Ansys. Ansys, we have find maximum one mysis stress, as you see here in Ansys. Maximum one mysis stress force is applied here. Oh, this is tensile force. We want to change it. You can change the direction, and you have inspiration. Okay, and if you want to know anything about this design and any other biomechanical problem, you can contact me at this email or at this WhatsApp number, +922426392275. Or you can see my LinkedIn, Affan Ahmed Khan, AFFANAHMEDKHAN. Type your LinkedIn ID, Twitter, anywhere, I am available for you for your help. Thank you very much.